I want to talk to you guys about resolving vectors, and what I mean by that is what do you do with a vector that is not in just a direction but is in multiple directions. Okay? So let's say that this is a vector, a displacement vector. Somebody walked this far in this direction, and I want to know how to deal with this vector. Now, we're used to dealing with vectors that go to the right or to the left. We can deal with that. We're used to vectors that go up or down. We can deal with those. But how do I deal with this vector that actually goes up and right? Okay? Well, it's easy, but I can't. I'm not going to leave it in this form. I actually want to resolve it into the parts that make it up. Okay? So what I mean by that is if there's a vector that is up and right like this, the exact same displacement can be given, or push or whatever, could be done by pushing in this direction and then going in this direction. Okay? And what we have here are what are called components of vectors, or vector components. Every two-dimensional vector has two components. And what I mean when I say two dimensions is it doesn't just move to the right and it doesn't just move up, it moves up and right. Okay? So the two components, this is the x component because it moves in the x direction. Okay? This is the x component of the vector, and this is the y component of the vector. And when we resolve a vector into its parts, all we do is we figure out what the values of these are based on what information we're given. Usually we're given an angle and a number, a magnitude. Okay? So let's actually work a couple of these problems so that we can get familiar with how we resolve vectors into their component parts. And I'm going to start with a nice, easy, simple one. So let's say I start with a vector and somebody walked this direction, and that's 30 meters, say, and this is 25 degrees north of east. Okay? So I'm giving you the direction. Well, that means when I actually go to find my vector, what I'm going to do is I'm going to draw that line, and you don't have to do it super precise. You're just trying to get a picture, a cartoon of what this looks like. So I have my vector drawn, and now I'm going to draw in the right triangle that goes with it. Okay? So I have that part, and I have this part. And all I'm trying to do is figure out what these two values, the x value and the y value, are. Okay? Well, this is the side adjacent to my angle, so I know I'm going to use the cosine function here. This is the side opposite my angle, so I'm going to use the sine function here. So this vector, and just for fun, I'm going to call it vector r. This vector is this direction, so I know the vector r itself is equal to 30 meters at 25 degrees. I want to know what the component is of x. Okay, so I want to know how far does x go, or how far does r go in the x direction. So we use that little subscript here, r sub x. And this is equal to whatever value we have in the x direction. So I know cosine of 25 is equal to adjacent x over hypotenuse, and the hypotenuse is the magnitude of my vector, so 30 meters. And now I can multiply both sides by 30 meters. And so I get 30 times the cosine of 25 is equal to x, whatever that is. So then it's just a matter of 30 cosine 25 on the calculator, and you get 27.19 meters. Okay? So the x component of this vector is 27.19 meters. The y component, there's lots of options now because now you know two sides of a right triangle, you know an angle, you can find whatever you want. I tend to just use the sine function, right? The sine function says that the sine of 25 degrees is equal to the opposite side, y, over the hypotenuse, 30 meters. Again, multiply both sides by 30 meters, and the 30 cancels on this side, and I get 30 times the sine of 25, and we get 12.7 meters. So the y component of r is equal to 12.7 meters. And this is easy because both of these are positive, but you do have to pay attention if you have a vector that goes in a different direction, right? So I'm going to pick a vector that's actually over here, all right? And I still have to establish a coordinate system, so that hasn't changed. I'm generally going to pick to the right to be positive, and I'm generally going to pick up to be positive. So I'm not going to change that. These are both positive directions. The difference is one is positive in x and the other is positive in y. So I've got to reflect that when I actually find my components of this vector. So let's say that this vector, this is some force, say, and it's equal to 27, well, yeah, all right, 27 newtons. And let's say that it's at 30 degrees above horizontal. Okay, well, that's fine, and so I'm going to put in my line that's horizontal. I'm just going to draw in a dashed line, and what I get, okay, is that means, well, which angle is 30 degrees? Well, it's this angle. This angle is 30 degrees because this is above horizontal. Okay, this angle, if I wanted to know that angle, there's 180 degrees in a line, so this angle is 150 degrees. Okay, so you could also say that this is 27 newtons at 150 degrees. Technically, all angles are measured counterclockwise from the x direction unless they tell you what they're measuring from. So if a force is 27 newtons at 170 degrees, that's over here and it's 10 degrees above this line. Okay, usually it's pretty clear what your angle is. Now, I still want the vector components, the x and y components of my vector, so the vector f is equal to 27 newtons at 30 degrees. I want the x component of f, and I want the y component of f. Okay? So I come over here and I say, well, this is the x part, this is horizontal, so I'm going to draw that in. There's my x component, and my y component, the vertical component of this vector, is here. Okay? So I'm going to do the same thing, but I've got to pay attention to my picture. Okay? So the y component, start with that, that's opposite my 30-degree angle, so I'm going to say that Fy is equal to the hypotenuse, 27, times the sine of 30 degrees. Okay? And as I recall, the sine of 30 is a half, so half of 27 is just 13.5. So this is 13.5 newtons. Okay? Now this actually is legitimate, and it checks out with my picture because this came out positive, and I know a vertical direction should be positive. But I'm going to be careful because when I try the same thing in the x direction, if I try 27, but now I want the adjacent side, cosine of 30, if I type that into my calculator, 27 cosine 30, it gives me 23.38 newtons. But that would imply that this is actually being pushed to the right, and it's not. Okay, so if I drew my picture, I can just go ahead and say that this is negative 23.38 newtons, which is why you should always draw your picture of what's going on. But you've got to be careful because the real angle that cosine uses is the angle measured from the positive x-axis. So if you actually use 27 times the cosine of 150 degrees, then you would come up with that negative 23.38, and that would include the sine. And so I know this one has to be negative. Okay? And even if you use the 150 for your sine, that's still going to be okay. It's still going to be positive. So you have to pay attention to either the picture to get your direction, or you have to use the angle measured from the positive x-axis.